Okay, this video is dedicated to Raylan. Anybody want to say hi, Raylan? Hi, Raylan. We hope you're doing well. We miss you. They should watch it. Maybe if you text her and say that we talked to her, maybe that'll work out. Okay. And the reason why we dedicate it to her is because we know that math is her favorite. Okay, so this is the big question. This is our unit. We want to learn about oblique triangles. What are oblique triangles? Oblique triangles do not have a right angle. So far, you've been able to do trigonometry with right angles. Well, congratulations. We were able to do that a while ago. So what about triangles that are not right? How do we work with them? So many triangles are not right triangles, but rather oblique. Let's use what we know about right triangle trig to derive a way to solve oblique triangles. So if we have these sides of a triangle, okay, we got A, B, and C. Question is, we don't have a right angle, so how would we go about it? We can't set up SOHCAHTOA, so we need to set up a new kind of formula. Now, I could just give you the formula, but instead, let's derive it, or rather prove that the law of sines is the formula that we use. I'm going to create a height, or a 90-degree angle. I'm going to use that in order to come up with a nice formula. So, who can tell me what is an expression for the sine of A? H over B. What is an expression for sine of B? H over A. Everybody see how Kayla got that? The nice thing is that both these expressions have an H. If they both have an H, I can solve for H. I multiply both sides by B. B times the sine of A is equal to H. And A times the sine of B is equal to H. Well, if they're both equal to H, then they should be equal to each other. So now we have a formula, so we can get rid of the H. Wouldn't you agree that if you look at a triangle, you might be given, say, side A or side B or angle A or angle B, but you probably wouldn't be given the height? So that's why we try to eliminate H in our formula. The very last thing I'm going to do is I'm going to divide both sides by AB. If I divide both sides by AB, you can see that the B's cancel. See that here the A's cancel. And so I get the sine of A over A is equal to the sine of B over B. This is our law of sines. If you're given a triangle ABC with sides little a, little b, and little c, then we can state that the sine of angle A divided by side A is equal to the sine of angle B divided by side B. And we could then also state that that's equal to the sine of angle C divided by side C. We could show that that's true as well. The key is that you must be given an angle, not an angle, and its opposite side. So as you look at this drawing here, I was able to eliminate the H, and you want sine of A divided by A, and sine of B divided by B. So you want angles and their opposite sides in this scenario. This will become our resource to be able to solve oblique triangles. To go to the first example, solve the following triangles. And when it says solve, it means find A, B, C, little a, little b, little c. A is 42, B is 80, and if I do my subtraction, I will find it. Good question. All right. I'll list my knowns. B is 80, A is 42, and A is 10. Obviously, you know how to figure out C right away, but before we do that, I'm going to ask you to do something else. Please go to your very back page of your notes and either have that handy or tear it off. That is your lifeline for the next test. Okay. Time to get back to some geometry. So, here we have it. I know that I have an angle side scenario. So what I do is I go to my flow chart. And my flow chart or decision tree says if you are given angle side, use the law of sines and you will have just one solution for your triangle. It works out quite nicely. And so let's solve that one together. We start with finding angle C. How do you find angle C? Subtract from 180. All three of these angles have to add to 180, and so you do get 58 degrees. Very good. Great. I'm missing two pieces now. Can I use SOHCAHTOA? Why can't you use SOHCAHTOA? There's no right angle. Can I use the Pythagorean theorem? Why? There's no right angle. So we're out of these options. So that's where we turn to the law of sine. So I set up sine of 42 degrees divided by its opposite side. If I didn't have its opposite side, I'd be in trouble. That's another lesson in a different day. That's equal to the sine of 80 divided by b. So you can see I have one variable that I'm now going to solve for. I cross multiply. B sine of 42 is equal to 10 sine of 80. Divide by sine of 42. Take out my calculator. I must make sure I'm working in degrees. As you can see, I just got done with calculus. At calculus, we only work at radians, really. So I go down to degrees. Let's see here. So 10 sine 80 parentheses divided by sine of 42. Make sure you close your parentheses in the appropriate region. Press enter at 14.72. So for B, I get 14.72. Now I have to find C, so I'll set it up again. Sine of 42 divided by 10 is equal to the sine of what? 58 divided by C. So I get C sine of 42 is equal to 10 sine of 58. If you look at my chicken scratch down here, you can see I have 10 sine of 58 divided by sine of 42. That's very similar to what I just plugged into my calculator, isn't it? So let's save ourselves time. We press second, enter, which brings back your previous entry. Then I can just go back and edit what I had, and I will change it from 80 to 58. 12.67. And I'm showing you these tricks now. These are things we do use in calculus almost every single day. Okay, so stuff we want to see. All right, let's look at our results. Yeah, how do I check to make sure that these results are reasonable? Reasonable. Okay, a few people have said it. Biggest angle, biggest side. Smallest angle, smallest side. And then the middle angle, middle side. That doesn't ensure it's correct, but at least it says it's reasonable. Okay? I mean, I could have transposed 6 and 7 here, and it would have been technically incorrect. However, it still would be reasonable. You see that? You try the next one on your own. Go. Separately. So here are your answers. It is an angle side angle problem. 141, 1227, 10, 3.3, and 7.21. Clap for Claire for being. 1, 2, 3. All right. Flip it over. Area is sometimes an issue. What if I take I have triangle ABC, and what I'd like to do now is I'd like to derive a second formula. That'll be the formula for area. And area, in terms of a triangle, has a formula that we're well acquainted with. Area is what? Half times base times height. Well, right now, as you look at this triangle, if I wanted to find the area of it, what is the base of this triangle? B. But I don't have a height, do I? So I will draw one, but I would like to get rid of it eventually. So I will place H there, but I want to get rid of H and use something else in its place. So A for the day. Who can tell me what sine of C is equal to? H over A. Great. My new expression has an H in it, which means I can solve for the H and then use it to substitute. So A sine of C is equal to H. I will take that and drop it right in there. So as I place that in, I have A times B times the sine of angle C. Therefore, that is my formula. The H is gone, and I now have a formula for the area of a triangle without its height. It's kind of cool. Now my pet peeve comes up. I can't stand it when we focus on the letters. Don't look at the letters and try to figure out the formula. Think of conceptually what's going on. If you are given simply two sides and the included angle, then you just take 1/2 times the product of the two sides times the sine of the included angle. That's the idea. As opposed to this, I can give you a formula sheet, and on this formula sheet, there's all three versions of the formula listed, but all people say, well, where's A, where's B? It doesn't matter. Just find two sides in the included angle, you're good to go. Don't think about the letters. It'll slow you down. So we'll see how easy this actually is. Go back to your example. And example 2 says find the area of the following triangles given those conditions. So if we have ABC, we know angle A is 75 degrees, side B is 12, side C is 15. Do you have two sides? Do you have the angle that is included between the two sides? So therefore, in order to find this area is simply equal to 1/2 times the two sides times the sine of the included angle. So notice I didn't write out the formula A, B, and C, but rather I just thought about it conceptually, two sides and the included angle. Oh boy. Nope. Somebody else? What did I do to my calculator? I reset it, so therefore, it's sitting in radians. second entry. 8693. You do the second one on your own. Go. While you're doing the next one, I'm going to hand out the assignment. Okay, what'd you get? Great. Not too hard, huh? If you can see by looking at it that it's, yeah. Okay. All right, look at your worksheet. Here we go. Please change the title of your worksheet. So I'm sorry I stole this from a different class that I teach. I just write college. And then Unit 6.4. So this is a Unit 6.4 worksheet for us. It's not 3.1. 3.1 would be for the different trigonometry book. And then within the directions, we want to solve the following triangles with a given condition. We also want to determine the area of each triangle. Everyone. It'll take you an extra 48 seconds. No, entirely, because it's that easy. Okay, here we go. So, if it says to solve, we have A, B, and C listed out. The reason why I created this so you could check your answers more quickly and efficiently, because it'd be all organized for you. Okay? So, I have the answer key all ready to go. You can view it tomorrow. A, B, and C, 85 degrees, 32 degrees, and B is 20. Side C, side A. You tell me, which of the 6 triangles is it? Angle, angle, side. Angle, angle, side, according to our decision tree, says one solution using the law of sine. Great, no big deal. We'll do it. It gets more complicated as we move along. Grab my worksheet. Here it is. I'll set it up. The sine of 85 over A is equal to 32 over 20. I cross multiply. 20 sine of 85 is equal to A sine of 32. Divide by the sine of 32. Type it in my calculator. Stupid calculator. I've been waiting for somebody to send me a TI-84 emulator, and people say they have it, but nobody ever sent it to me. Waiting for it. Obviously not. All right, so we give it a shot. 20 sine of 85, parentheses divided by sine of 32. And I get 37.60. We're going to round to the nearest hundredth for this assignment. Is it right that A is larger than B? Yes. Okay, what is angle C? 63, because they should all add up to 180. So then to find side C, we go sine of, and I like to use the same setup that I had before. So sine of 32 over 20 equals sine of, now instead of 85, I'll choose 63 over C. To cross multiply. You guys are able to write smaller than I can. And again, the only thing that's different about this compared to what I have typed in is the 85 and 63. So I'll go second entry to do that copy and paste option. And I'll go back up and I'll edit it. Instead of 85, I will choose 63. And so I'll do the same thing again. Go back. I get 33.63. Are my answers reasonable? They are reasonable. Now, here's the bigger question. I erased it. So what was A again? B. And then side A was 37.6. Side B was, side C was, okay. We now need to find the area. So you have three options. This group right here, on my right-hand side, you guys are going to do the blue option and come up with the area. The group that's in the middle, you guys are going to do the green option and come up with the area. Those of you who are off on my left-hand side, you are going to do the red option. You choose any. Go ahead, quick do it. Come up with the area. We should all come up with the same thing. What do you get? So you guys might be off a little bit in terms of your hundredth or thousandth or whatever, but that's fine. This is very close, 335.02. It doesn't matter which of the three you choose, okay? All right, last example. Next one. Set up my triangle. A, B, C. A is 40 degrees, side A is 10, side C is 7. 40 degrees, A is 10, side C is 7. Here's the problem, folks. Here is the problem. What'd you say? We have two sides. What kind of triangle is this? Side-side angle. The angle is not between the two sides. If it was angle B, then it would be between the two sides, correct? So here's the problem. This is crucial, you guys, because I'm setting up what we're doing tomorrow. So especially for those of you who are not here tomorrow, you want to see this. This is side-side angle. And the problem with side-side angle is you might end up with one solution. You might end up with 0 solutions. And you might end up with 2 solutions. So that's the ambiguous scenario that we look at tomorrow. But today, I can at least show you why we come up with what we do. For your assignment today, you will only get one solution. You don't have to worry about more than one solution. But I will show you why it comes up that way. Here's what we do. We take the sine of 40 divided by 10 is equal to the sine of C divided by 7. What is different about our solving in this scenario? We're going to use sine inverse. We're solving for an angle. So we get 7 sine of 40 is equal to 10 sine of C. We divide both sides by 10. I'm going to see what I get. 7 sine of 40, parentheses, divided by 10. And I get 0.44995. Yes, but think about it, folks. You just did a graphing of sine and cosine. This is positive. Which quadrants is sine positive in? 1 and 2. Okay? If sine's in the first quadrant, it will be between 0 degrees, and that's an acute angle. If it was in the second quadrant, it would be between 90 and that would be, here's the deal. Later on, we don't know whether this is referring to the first quadrant or the second quadrant. We don't know whether it's referring to the acute angle or the obtuse angle. Here's the other piece. What is the maximum value that sine can have? 1. What's the minimum value? Negative 1. Can sine take on a value of 0.4495? Could it take on a value of 1.44? No. So you can see how sometimes you get 2, sometimes you get 1, sometimes you get none. And that's what we have to be careful with. For everything you do today, you will come up with just 1. I've worked the problems to make sure that happens. In order to figure out the angle, I sine inverse the answer. And I get 26.74. What can I now find as well? How do I find B? Subtracting from 180, I get 113.26. How do I find side B? Pythagorean theorem? Not a right triangle, can't do that. So I set up sine of 40 over 10 equals sine of 113.26 over B. All the problems on the left-hand side, you'll be solving for sides right away. All the problems on the right-hand side, you'll be solving for angles right away. That's how I've divided this up. Remember, don't forget to write down your area. And in this case, 0.5 times 7 times 10 times the sine of 113.26 is 32.16. So don't forget to calculate area. I did the 2 example problems for you. You have 10 problems to do on your own. That's your assignment on your worksheet. The answers will be ready to be checked. Tomorrow, I have the answer key ready to go. Again, tomorrow's the most important lesson of the unit. Okay? I sure will.